What is going on, guys? Today I'm going to show you how to make your own injector. It's going to be a very simple injector. It's going to use load library to inject your desired DLL into your target process. So let me just show you how this works. We got our injector and then we got the target program here. So our injector is going to store the DLL path, which is just the directory of the DLL. So what we're going to do with our injector is we're going to allocate memory to our target program, and in this allocated memory we're going to write the process memory, and we're going to store the DLL path into the target program. So once we've stored the DLL path into the target program, we're going to use, in our injector, we're going to call a function called create remote thread. So what this is going to do is it's going to create a thread of execution in the target program, and we're going to get it to run a function called load library a, and that's how this injection technique gets its name. It's called a load library injector. So what that does is it calls load library from within the target program, and for the parameter of that function we pass the memory where the DLL path is stored inside of the target program, so that the target program can load the DLL that we want. And that's basically it. Very simple explanation, very simple injection technique. Let's start coding it. So for the injector, you want it to be a console application. So in a new project, you just go Visual C++ and then console application. I'm just going to call it Injector YT. So once you've created your solution, you want to make sure that your injector matches your target program. So it's either going to be x64 or x86. So for this one, I'm going to be using Paint as an example, and Paint is x64. So I'm going to keep this one in x64. So let's start off with the includes. I'm going to have to include Windows. Windows.h, and after that we're going to need to include string and thread, and lastly we're going to need to include libloader API, and this is where load library is stored. So after that we're just going to do using namespace so that we don't have to type std, and then we're going to code some functions here. So the first function we're going to code is a function to grab the target program's ID, process ID. So it's going to be a void, and we're just going to call it get proc ID, and for the arguments we're going to need the window title, and dword, we want it to be passed by reference, and that's going to be the process ID. Okay, so we got two parameters here. We got the window title and where we want to store the process ID, and that's being passed by reference, so we can directly modify that variable. So this is just going to be one line of code, very simple way to get the process ID of a target program. So we're going to call get window thread process ID, and this requires a handle to a window and a buffer for the process ID. So for the handle to the window, we're just going to call another function inside, and we're going to call find window, and we're going to pass null, and then we're going to put window title here. Okay, so this is going to find our desired window, and it's going to return a handle to the window. And I'm getting this error here. You guys will probably get this error as well. To fix this, you need to go into your project settings. Not that one, this one. And you want to go into general, and here at character set, you want to change it to multi-byte. Apply and then click OK, and then the error will disappear. And next we're gonna want to put the process ID, but it wants us to pass it by reference, so we put the ampersand here. If you don't know what that means, just search it. It's just called pass by reference. It's just a way to allow the function to directly modify the variable instead of having to duplicate it. The next function we're going to do is it's just going to be a function to help us display error messages, so that if our injection fails, we can understand what the problem was a lot easier. So it's going to take two parameters, the error title and the error message, and basically it's just going to show a message box, and it's going to say the error message and title, and then it's going to exit, and we're going to pass -1 as the code. So what this does is it just shows a message box with the error message and the error title, and then it just exits the program with the code -1. I'm just going to change these zeros to null. This doesn't affect the program at all. I just like to use null because that's my name. So, and the last function we're going to make here is a bool, and it's going to check if the DLL file exists. So what we're going to do is we're going to just create a buffer here using the stat struct, and we're just going to return the result of this function here. Okay, so what this is doing is we're just creating a random buffer here of the stat structure. We don't really care about the buffer. We don't care what this function's putting into buffer. Basically, we're just making sure if the function is successful. So what this stat function does is basically it just gets information about the given file, and it puts the information into the buffer, and what we're doing is we're just checking if that function actually worked. So if it returns 0, that means it worked. So that means that this file actually exists because this function could access that file and get information about it. So if the file exists, it returns true, otherwise it returns false. Okay, so now we're going to code the main, and we're going to need a couple variables here. So the first one is going to be the process ID that we get. I'm going to set that to null. Next is we're going to need DLL path, and it's going to be a char array, the size of this max path definition. What this is this is the maximum size that a file path can be, which is 260 characters. Next, we're going to need a constant char pointer, which is going to be the DLL name, and you can change this to whatever name your DLL is. I'm just going to put test DLL. And next, you want the window title. And I'm just going to make this the title of paint. Now, if you're using this for your game or whatever target program you want to hack, you need to put the window title, not the name of the file or the process name, the window title. So the way you find the window title in Windows, pretty much you can just hover over the window here, and it's whatever's up here. So for paint, we're going to want to do untitled-paint, and you want to write it out exactly as you see it. So I'm just going to write untitled paint, and that's it. I'm going to double check. Yep. Okay. So that's the window title. So that's all the variables we need. We're going to do an if check here, and we're going to say if the file doesn't exist, then we're going to throw an error, and basically all we're going to say is we're going to say the function name, and then we're going to say the message, which is basically the file doesn't exist. Okay, so we've checked the file exists, it does exist. So next we're gonna next thing we're gonna do is get the full path of the DLL file. So it's gonna get the full directory of where it is from like the C drive. So we're going to do another if check, and we're gonna call the function get full path name. And for this one, we're gonna pass the DLL name, max path, and then DLL path. And for the last one, we don't really care about this parameter, so we're just going to put a null pointer. And then we're going to do the if statement. And if we can't get the, we need to put an exclamation mark here. So if this function doesn't work, we're going to throw an error. And we're going to say get full path name, and the message is going to say failed to get full path. Okay, so we've checked if the file exists. We've gotten the full directory of the DLL. Next, we're going to need to get the process ID. So we're going to just call get proc ID, and we're going to pass the window title and the process ID variable we have. Now, because in the function definition we have the ampersand in this line here, when we're calling it we don't need to put the ampersand again. Just putting the variable name there is going to pass it by reference normally. So once we get the process ID, we're going to check if it actually worked. So we're going to say if process ID is still null, which means since we set it to null up here and then we call the function, if this function didn't change the value of it at all, which means it failed, we're just going to throw an error. So we're going to say wait, what am I doing? So we're going to say get proc ID, and we're going to say failed to get process ID. Okay. So after we get the process ID, we're going to be able to open a handle to the process. So we're going to make a handle. And we're going to call open process. Open process lets us open a handle to our desired process. So for our desired access, we want all access to the process, and it's going to be null, and process ID is proc ID. Okay, and we're going to check if the handle is valid. If it's not valid, then we're going to throw an error, and we're going to say open process failed to open a handle to process. Okay. After we got a handle to the process, we're going to allocate memory in our target program. So we're going to create a void pointer. We're going to call it allocated memory. And this is going to point to the allocated memory. So we're going to call virtual alloc ex, and we're going to use our handle. We're going to pass a null pointer. And for the size, we're going to do max underscore path, and we're going to do mem reserve and mem commits. And lastly, we're going to give the protect flag, which we want it to be read and write. So what we're doing here is we're calling the virtual allocation. So we're calling this function, we're passing our handle to the process, and we want the size to be the size of max path. So the reason we pass mem reserve and mem commit is so that we reserve the memory, and you can't edit the memory unless you commit to the memory. So we need to commit to it so that we can actually write to that memory. So once we call that function, we want to make sure that it worked. So we're going to do a check. And if this pointer isn't pointing to anything, we're going to throw an error, and we're going to say the function name and the error. So failed to allocate memory. Okay, so once we've allocated the memory, then we can write to that memory. So we're going to call write process memory, and we're going to do an exclamation mark to check if it doesn't work. So write process memory, and we're going to want to pass the handle to the process. We're going to want to pass the buffer, which is DLL_path. Then the size is going to be max path, and this is just going to be null. So this actually has to be a null pointer. So if that fails, we throw an error and we say write process memory failed, and we're going to say failed to write process memory. Okay. So what this is doing here is this is writing the DLL path into the target program. So like I explained here, what it's doing is it's getting the DLL path from our injector, since we stored it, and it's writing it into the allocated memory in the target program. Next, we're going to create the remote thread, which executes the function in the target program, which uses the DLL path. So we're going to call create remote thread. We're going to call create remote thread, which returns a handle. So we're going to store that in h_thread, and we're going to call the function, and we're going to pass the handle to the process. Next is going to be a null pointer. We don't care about the attributes. And then we're going to pass null. And this start routine is where we pass load library. So we say LP start routine, and in these brackets here, we say the function that we want it to execute, which in this case we want load library A, and that's going to load the DLL library into the target program. Now for the parameter, if we look at load library A, this function requires one parameter, which is the directory to the file which you want to load. So since we've stored the path to the file, we just give it the address of where it's stored, which is the allocated memory variable. And then for the creation flags, we're just going to pass null, and then we're going to pass a null pointer for the thread ID. So we're going to make sure that this thread actually was created successfully. So we're going to check if the handle is invalid. If it is, then we're going to throw an error, and we're just going to say create remote thread. And then for the error message, we're going to say failed to create remote thread. That's it. Now we just need to close the handles and free the memory. So we're going to call close handle, and we're going to pass the handle to the process. Then we're going to free the memory which we allocated by calling virtual free x, and we pass the handle to the process and the allocated memory, and then we just pass 0. I'm actually going to change that to null, and then we want it to release the memory. And lastly, we're just going to show a message box to let the user know that we successfully injected. And we're going to say success. Okay, so that's the injector. Let me just give a quick rundown of everything. So this is the function that gets the process ID, uses the title of the window, and that's all it needs to get the process ID. It just finds a handle to the window, and then with that handle to the window, it gets the process ID, and we store it into the parameter that's passed here. And then we got our error function, which just shows a message box of the error and then exits the program. We got our file exists function, which just checks if the file actually exists and then returns true or false. We've got a couple variables here in our main. DLL name, this is where you put your DLL name that you want to inject. This is the window title of the program that you want to inject into. We check if the DLL exists. Then if it does exist, then we get the full directory of that DLL. Then we get the process ID of the target program. Then we get a handle to the process. Then we allocate some memory, and then we write to that memory and we store the DLL path in the target program. And then if that all works, then we create a thread in that program and we make it call load library A, and we give it the memory where the DLL path is stored. And if that all works, then we just close the handle to the process, we free the memory, and then we say that we successfully injected. So I'm going to build this and I'm going to check if it works. Okay, so I actually made an error in this write process memory call. These arguments are wrong. So you want to pass the handle to the process, and then you want to pass the allocated memory, and then the DLL path, and then you want to pass max path, and lastly you want to do a null pointer. So that should work. I'm going to create a really quick test DLL. So I'm just going to click a new project. I'm going to go C++, and I'm going to go desktop and then DLL. I'm just going to call this test DLL YouTube. Okay, so in the DLL, I'm just in the DLL main.cpp here. I'm just going to include windows.h. I think that's all I need to include here for the errors to go away. And in the case DLL process attach, so if we attach to the process, all I'm going to do is I'm just going to call a message box. And I'm going to say null, and I'm just going to say hello from inside the process and success. Okay, so if we attach to the process, we just throw a message box and we're going to say hello from inside the process, and that's it. And also for the DLL, you want to make sure that it matches your injector and your target program. So if your injector is x64, then you want the DLL to be x64, and you want the target program to match as well. So built, I've got the test DLL in the same folder as the injector, and I'm going to run, and it says successfully injected, and there's the message box from the DLL which is saying hello from inside the process. So the DLL has been injected into Paint successfully. So there you go, you've got your own injector. You just change the name of the DLL here and the name of the window title, and you can inject into whatever you want. So thanks for watching. If you want me to do another video showing a different injection technique like manual mapping or thread hijacking or something like that, let me know. And thanks for watching.